An SLLlist, or singly linked list, provides an efficient implementation of a stack or a queue. The basic building block of an SLLlist is a node. A node has two parts, a piece of data that we call X, and a pointer to another node that we call Next. The nodes of an SLLlist are linked together, one after another, through their next pointers. The SLLlist itself consists of a pointer to the first and last node in this sequence. To add a value to the front of an SLLlist, we first create a new node U containing the value we want to add. Next, we set U's next pointer to the first element in the list. Finally, we set the SLLlist's first pointer to point to U. To add a value to the back of an SLLlist, we create a new node U containing the value we want to add. Then we set the next pointer of the last node in the SLLlist to point to U. Now U is the last node in the list, so we set the SLLlist's last pointer to point to U. Removing a value from the front of an SLLlist is easy. We just change the list's first pointer to the next node of the first node. So far we've seen that we can add and remove elements from the front of an SLLlist, and we can add elements to the back of the list. This means we can implement the push and pop operations of a stack interface by adding and removing only at the front of the list. We can also implement the add and remove operations of the FIFO queue interface by adding at the back and removing at the front. Unfortunately, we fall just short of being able to implement all four deck operations, since there is no efficient way to remove the last element from an SLLlist. If you ever find yourself implementing an SLLlist, there are two cases that need special care. When we add a value to an empty SLLlist, we have to set both the first and last pointer to the newly added node. Similarly, when removing the last element from an SLLlist, both the first and last pointer should be set to null. To summarize, an SLLlist can implement both the stack and FIFO queue interfaces so that each operation takes constant time.